moving on to question 3 now, we have a question here to do with integration, and it's related to the hyperbolic trig functions, and it's using substitution, and we're asked to state clearly what that substitution is. And then part B is just a dead brief one on the mean value theorem. Okay, so just 2 marks for that. So let's jump into question 3a. Let's have a go at tackling it. So we've got f of x is 1 over the square root of 4x squared plus 9. And we have to use this a substitution here that should be stated clearly to give the integral of f of x dx being equal to a hyperbolic sine inverse bx plus c. So to get my substitution, if I do it over here, I'm going to use a right angle triangle. If that's my right angle there, and my largest length here, that's going to be 4x squared plus 9. Okay, well what that must mean is that one of the sides must have been the square root of 4x squared, so 2x, and one of them must have been the square root of 9, so 3. Okay, now I can get this in terms of tan theta, so tan theta, well what will tan theta be? Well that'll just be opposite over adjacent, so 2x over 3. Okay, and then we can now put this in terms of x for my substitution back into f of x. So x is going to be equal to 3 tan theta over 2. And next step, because we're using substitution, let's work out dx as well. So dx, what will dx be? Well, that would just be 3 over 2 sec squared theta d theta. Okay, so we've got all the preliminary kind of like information we need for this question. Let's jump into actually substituting this now. So going over here, I'm integrating f of x with respect to x, so it'd be the integral now of this dx. Okay, so integrating this now, all I'm going to do is substitute my x equals into here, and I'm going to put dx on the numerator. So what I've got now is dx over the square root of 4 lots, squaring x now, so that's going to be 9 over 4, tan squared theta plus, I've got the 9 as well, plus 9. Okay, so I kind of underestimated just what I needed there for that, so there we go. And don't forget, this is going to be with respect to theta once I put my dx in, okay? So if we do that now, this is going to be the integral of 3 over 2 sec theta, sec squared theta, sorry, d theta. And this is going to be over this now, but I can simplify here. If you've got 4 lots of 9 over 4, that'll just cancel to give you 9, and I've got 9 tan squared theta plus 9, okay? So I can actually factorise in the denominator. So this will give me 9 tan squared theta plus 9. Factorising that now though, that's actually going to give me, so keep the numerator the same, 3 over 2 sec squared theta. My denominator now, well that's going to be the square root of 9 lots of what tan squared theta plus 1. Okay, and this should look pretty good now, right? And hopefully it's jumping out at you why this is good. And the reason for that is because we can use our A-level maths trig identities. Okay, so tan squared theta plus 1, well that's just simply sec squared theta. So what we actually have now is the square root of 9 sec squared theta. And then we can square root that. So this is the integral now. Of the square root of 9 sec squared theta, which will just give me 3 sec theta. So that's good. Now we just need to simplify this. So simplifying all this now, all you're going to get left with is the integral of a half sec theta, and this is with respect to theta, so d theta. Integrating this now, nice and straightforward, just the integral of sec theta. You can take the half out to the front if it helps. So this is just going to be a half ln. In the bracket here, I'm going to have sec theta plus tan theta plus tan theta. Now, we can use the given forms in the book because we know it's got to be a hyperbolic sine inverse, b of x, okay? And we can use the the formula book for maths, which gives you the forms of what this is going to be. So using that, I'm just going to sub everything in now of what will be appropriate. So it's going to be a half ln. Okay, it's going to be 2x over 3 because it's a half ln tan theta plus sec theta here. So if I just put this in first, I'm going to get to the formula book bit, but first I'm just replacing what we've got here. We've got sec theta and we've got tan theta, but we know tan theta is 2x over 3. So this is 2x over 3. 2x over 3 and sec theta, well, that's going to be the square root of tan squared theta plus 1. Okay, so if I try and get all this down, plus the square root of sec, the square root of this here to give me just sec theta, so it's going to be the square root of 1 plus tan theta, which we know is our tan squared theta, which is 2x over 3 squared. So I'll write it all down. 2x over 3 all squared, like so. Okay, so we'll hopefully just get there with enough room. But this now is in the appropriate form for hyperbolic sine inverse. If you look in your formula book, you'll see that this is exactly in the form that we need. So just writing that out as it is now. Therefore, we're going to obtain that u is going to be equal, I should call it probably theta in my case. Theta is going to be equal to a half hyperbolic sine inverse 2x over 3 plus c. And there we have it, that's part A done. So there's some tricky integration going on there. That part's not quite as straightforward as part B, but it's necessary to get to part B. So if we clear that, let's jump straight back into this now with part B. So part B, we have to find in exact form, in terms of natural logarithms, the mean value of f of x over the interval 0 to 3. So to find this now, this is going to be the integral of, so if I do it, so it's going to be the integral of b to a, or a to b, of f of x dx, and on the outside here, you've got 1 over b minus a, so 1 over b minus a. So, if I had to do that now, what will that give me? Well, b, so my b here is going to be 3, that's your upper limit here of the interval, and your a is your lower limit. So it's going to be 1 over 3 minus 0, so 1 over 3. In here now, we've got f of x. We've expressed it in this form. So it's the very last line that I just wrote, so it's going to be a third of half hyperbolic sine inverse minus 1, and it's of 2x over 3, so 2x over 3. And I'm doing this again between the limits b to a. So that's going to be 3 to 0. And now we just got to evaluate this for the, the last mark. So this is going to be a third of a half of hyperbolic sine inverse. Now, if I'm putting 3 in here, I'll get a value. If you put 0 in here, you're not going to get a value, right? Because hyperbolic sine will be 0 when x is 0. So that's not going to give you any value there. So we'll put this in now. It's going to be 2 times 3 over 3. Like so. Keep simplifying this now. It's going to be a third. And notice now we can use the hyperbolic sine and put it in the logarithm form because it wants it in terms of logarithms. So just like the last line of wicking we had where it was a half ln 2x over 3 plus the square root of 1 plus x 2x over 3 all squared, we're going to do that again. So put it in that form. It's going to be a half ln. In the bracket here now, it's going to be 2 plus square root of 1 plus 2 squared. Because it's 2 times 3 is 6, divided by 3 gives me 2. Okay? And then evaluating all this, I'm just going to get 1 over 6, a third, times a half, 1 over 6. 1 over 6 ln 2 plus root 5. And there we have it. That's part B fully complete for question 3.